Welcome to XField. XField has been developed to give geoscientists the opportunity to model and integrate potential field data in their interpretation environment. Gravity gradient, conventional gravity, and magnetic data can be interactively modelled in XField. This video is the first in a series which aims to get the users up to speed quickly. Incidentally, XField does have a rather extensive manual which can be found in XField by going to Help, then Reference Guide. However, we do appreciate that sometimes it's just easier and quicker to watch a short video. This video demonstrates XField 1.8.4 for OpendTect 5.0. This first video covers how to load potential field data into OpendTect ready for use in XField, and also how to start XField. Here we have an example project. The data available in this project consists of seismic, interpretations and well data. Conventional gravity and gravity gradient have been calculated from a synthetic density volume of this area. It is recommended that potential field data is loaded into OpendTect as a horizon attribute. This enables the user not only to QC the data prior to modelling, such as checking the potential field data is situated in the correct place, but it also allows the user the opportunity to move the potential field grids up and down and make comparisons with features in the seismic data. Now we'll quickly run through how to load data from a text file into OpendTect as a horizon attribute. Here we have an example text file that we might choose to load into OpendTect. This file contains x, y, a fake z value, and the GZZ and GZ amplitudes. To load this file, go to Survey, Import, Horizons, ASCII, then Geometry 3D. Although this option is called Geometry rather than Attribute, OpendTect will let us import attributes at the same time as horizon geometry properties. Simply select the file location, add the attributes, fill out the information regarding header size, the format definition should be filled out in accordance with the columns in your text file. For this file, these column numbers are correct. Lastly, change the output horizon name as desired. Okay, that seems to have worked. Now to QC the data. Right-click on Horizon in the toolbar, then select Horizon. Change colour as desired. The horizon will initially be set to the Z value specified in the file, which for our data was 0. We can change to GZ or GZZ by right-clicking on the attribute, then going to Select Attribute, then Horizon Data, and then selecting the appropriate item. So maybe we'd like to move our surface down to compare with features in the seismic, or for ease of viewing. Users can move the surface on which attributes are displayed by right-clicking on the horizon name and going to Tools, then Shift. Simply enter the shift range and move the slider bar or enter the depth in the text box. XField can load potential field data straight from a text file. However, we would always encourage users to load the data in a 3D window to QC prior to modelling. We'll return how to do this later in video 3. Now we have our potential field data loaded into OpendTect, we can proceed to modelling in XField. XField is launched from the toolbar at the top of the OpendTect window.